going to quickly review kinetic and potential energy before you start your lesson in Nearpod today. Kinetic energy is really easy to understand. It's the energy of motion. Potential energy seems to give people a little more trouble. Potential energy is when something is not moving, but where people get confused is that most objects have some kinetic and some potential energy at the same time, or maybe they go back and forth between potential and kinetic energy. So let's go ahead and take a look at potential energy. Right now, this person has stretched the rubber band. They're not moving. What type of energy is this? This is a great example of potential energy. It has potential energy because rubber bands are elastic. When she stretched it, she gave it potential. When she lets it go, what will it do? Well, of course, it will move. So that's going to turn into kinetic energy. Watch. So she gave it potential energy when she stretched it. When she let it go, it moved. So she gave it potential energy that turned into kinetic. Potential not moving, kinetic moving. Here's another example of stretching something. Just like the rubber band, when we're doing archery, you stretch the bowstring. When you let it go, it turns to kinetic energy. So notice how she pulls back the bowstring. She only pauses for a split second there, but she's giving it potential energy there. And notice how she pauses, then lets it move. Here's an example of an archery fail. Notice how he doesn't really stretch the string, so doesn't give it much potential energy. It just kind of falls. It still had potential energy though, right? It did move. It had the potential to move. When he held it still, it had a little potential energy, but it just kind of fell down. Most things with potential energy, though, we're not really talking about stretching. We're just talking about gravity. So let's call that gravitational potential energy. This is the energy that's stored in something due to gravity. Look at the water bottles. Are they moving? No, they have potential energy. They have the potential to move. How will gravity make them move? Well, gravity pulls things towards the center of the earth. So with maybe just a little help from this cat, gravity might be able to take over. Right now they have potential energy. Watch it turn into kinetic energy. See how it had the potential for gravity to move it? But as soon as it moves, that becomes kinetic energy. So potential energy turns to kinetic when it starts to move. Here's another example. Look at these tall shelves. Do you think there's a lot of potential energy here, specifically gravitational potential energy? Sure there is. What could gravity do with all those things on high shelves? Well, it would pull them down towards the ground. Watch what happens when we bump it just a little bit. Great example of some gravitational potential energy. Gravity pulls things down. When they're not moving, they have potential energy. Now it's kinetic because they are moving. A roller coaster is a great example too. So if we look at our roller coaster can go from one form of energy to another. Watch the little graph change. Notice how it's not always just one or just the other. It can have both, and that's why it confuses people. So if I were to pause this, let's try to pause it at the top of the big hill. Notice it's going really slow, so there's a little kinetic energy because it's moving, but it's not moving much. So it doesn't have much kinetic energy, just a little bit of moving energy. But it sure does have a lot of potential energy. Let's say when they were building this, there was supposed to be a bolt right there holding it all together, and they never put it in. And the whole thing collapses. Where is this roller coaster car going to go? Well, crash to the ground. Hopefully that doesn't happen. Hopefully it stays on the track. But even still, gravity can pull it down. So the higher it is, the more gravitational potential energy it has. The potential for gravity to pull it down towards the ground. For those of you who really like to think of things mathematically, here's an example that might make a little more sense to you. So the girl's holding the ball and then she drops it. So you can see three different stages. When she's holding it at the top of this hill or cliff or whatever it is, We calculate gravitational potential energy with weight times height. Let's assume the red ball weighs only 1 Newton, and she's 5 meters off the ground. 1 times 5 is 5 joules. It has 5 joules of gravitational potential energy. Well, when it's halfway down after she lets it go, the ball still has a weight of 1 Newton, but now it's halfway down, so it's only 2.5 meters off the ground. It's about half as high off the ground as it was before. Look at our gravitational potential energy. It's half what it was at the top. So instead of 5 joules, it's only half of that. What about down here at the bottom? Does it have the potential for gravity to pull it down? Of course not. It's sitting on the ground. If something's sitting on the ground, it can't be pulled down by gravity. There's no potential for gravity to do anything. Gravity's already done its thing. Let's calculate this. The ball still has a weight of 1 Newton, but now it's 0 meters off the ground. 1 times 0, that is 0 joules. There is no gravitational potential here because gravity can't pull something down when it's already down. Now think about this. Let's say we want to get the ball from here back to the top of the hill so she can drop it. How are you going to do that? Well, it's going to take some energy, isn't it? Maybe some kinetic energy. Maybe a person comes along, grabs that ball, and throws it back up the hill to the girl. Well, you have to use your muscles to do that, so you are doing work on that ball as you throw it, using your muscles for kinetic energy. All right, hopefully that helps a little bit. And if you have any questions, make sure you send me an email and I can help you out.